everyone, it's Mr. Canfield. Today we start our unit on quadrilaterals and other polygons. So we're going to start out with a card sort activity. So the way this card sort activity works is there's going to be a bunch of terms, like rectangle is a term, and that's a rectangle. And then there's all these descriptors, and I need to find groups of three where the name goes with a picture and then the descriptor. So like rectangle, there's a rectangle, it's got four sides. And I just keep going until I have all the matches possible. So let's see, let's see, this one says quadrilateral. That's literally any quadrilateral. I'm actually gonna hold off on that one. Let's see, this shape. That shape is called a rhombus. So it has four congruent sides. All right, let's see. Here's this picture. You know what? That looks like just some random quadrilateral. And let's just keep on laying things out. So I have room for four here. So let's see, I've got the word parallelogram. I've got the word, oh, this looks like a parallelogram. Two sets of parallel sides. Oh, that's what it is, all right. Let's see, then we've got a kite, a trapezoid. Oh, here is the trapezoid. We have isosceles trapezoid, okay. Oh, and here's the isosceles trapezoid. Oh, here's another quadrilateral, interesting. Maybe we'll see another one of those. Yep, right there, boom, quadrilateral. Let's see. And I know we're missing at least one. Oh, here's the kite. It's funny, kite looks like a kite. The one that I'm missing is square. So I'll just put square off to the side. There's a square. So the thing about the square is all four sides are congruent and it's four right angles. So that is the description of square. Four congruent sides, four right angles. So I have three more to place. One set of parallel sides, that's a trapezoid. And then an isosceles trapezoid is one set of parallel sides and one set of congruent sides. Interesting, I don't see that as one of my option choices. Wait a minute, four sides. I feel like I've got something more specific that I can do. I can just put four sides on a regular quadrilateral. Two sets of congruent sides, congruent, but that's two sets of congruent sides as well. So I think we're gonna place it there because this is two sets of congruent sides and four right angles. Oh, so maybe this is our four right angles. Let's see, one set of congruent sides. This only has one set of congruent sides. It also has one set of parallel sides, but they didn't include that in quadrilateral. So that's my version of, like, if I was doing this card sort. There we go, that's everything. Let me mix it all back up. So now, here's the trick. Pick one of those cards that you saw. Any one. Just try to remember it. Picture it in your mind. It's this one. No, just kidding. I was like, wow, this looks a lot like some card magician on YouTube. All right. So that leads into who's in command. So you just finished watching a variety of matching a variety of shapes to their names and descriptions. Let's look at some of these descriptions more closely. Okay, a parallelogram. We want to write down all descriptions that are true for that shape. So a parallelogram, it has two sets of parallel sides. That's true. Four congruent sides? No, it doesn't have that. Exactly one set of parallel sides? No, because it has two. Exactly one set of congruent sides. If you remember what a parallelogram looks like, it actually has two sets. Let me grab the pictures for these while we do these. So here's our parallelogram. Parallelogram, those are congruent and those are congruent. That's a thing. So these exactly one, we're not going to have 4 right angles. Nope, not 4 right angles. 4 sides, yes. Spoiler alert, every single one of these has 4 sides, because that is what the word quadrilateral means. Quadra, 4, lateral, line, 4 line. All right, trapezoid. Let's see, let's grab our trapezoid. There it is. Trapezoid. So trapezoid has 1 set of parallel sides, so that's C. 2 sets of, no. 4 congruent sides, no. The sides aren't equal, and those are the only 2 parallels. We don't know if anything's congruent. 4 right angles, nope. 4 sides, yep. So that was just C and F. Oh, excuse me, boring myself to sleep. Has nothing to do with that I have small children at home. All right, isosceles trapezoid. Let's grab that one. Here it is. Boop. Isosceles trapezoid. So it's got the 1 set of parallel sides. So we got C there. 4 congruent. I forgot to look at A and B. Not 2 sets. Not 4 congruent sides. Okay, so yeah. C, yes. Exactly 1 set of congruent sides. Those are congruent. Those 2 sides. So yes, that was D. 4 right angles? No. Okay. Now let's move on to the rectangle. Rectangle. Boop. All right. Here's our rectangle. You see 4 right angles. Let's see. So I knew, well, start at the top. Do we have 2 sets of parallel sides? Well, these right angles are showing us that those are parallel and those are parallel, so yes. 4 congruent sides? No. We have 2 sets of congruent sides, but not that. So let's see, C, exactly 1 set of parallel sides? No. Exactly 1 set of congruent sides? No. 4 right angles? Yes. So there's more things we could have put over here. This is just the ones that we're looking at. So we we had 2 sets of parallel sides. We'd also say 2 sets of congruent sides. We could have that for this one. 4 right angles, yes. 4 sides, okay. Let's pull out the rhombus. That is not the rhombus, but I'm gonna need that in a minute. Okay, here's our rhombus. Boop. All right, let's see. So, key thing about rhombus is it has 4 congruent sides. That is the key marker that is going to help us determine what a rhombus is. Oh, excuse me. It is also true that it has 2 sets of parallel sides. It is, in fact, in the family of parallelograms. Not C or D. 4 right angles, no. 4 sides, yes. Okay, so A, B, F. And then square. Let's see, where's my picture of a square? You know, square is probably the hardest picture to imagine here, so I get why we're, no, just kidding. All right, there's our square. So, 2 sets of parallel sides, 4 congruent sides, exactly 1 set of, nope, exactly 1, nope. 4 right angles, yes. A, B, E, F, wait, that's not how that goes. All right, then a quadrilateral, our last one here. These both fall in that category. So the thing that's true about these, the only thing that these are going to have in common it's guaranteed is that it has 4 sides. So, all right. So which description is used most? Gee, I wonder. That one. Why? Because that's what a quadrilateral is. It's got 4 sides. So I'm going to cheat a little bit and keep my, I don't know if you can hear that. Someone's blowing their nose in the hall. Sorry that I didn't have the foresight to close my door. So a good word for this is, it is the most general. It's the most general description. So why do you think some shapes have more descriptions than others? So some of these are special cases of other shapes. So for example, a parallelogram is a special case of a quadrilateral. A parallelogram is a quadrilateral that has two sets of parallel sides. So they all have this general property, and then they get more specific properties about them as well. That's kind of like saying, I want to ride in a vehicle. Well, what kind of vehicle? Well, I want to ride in a car. Well, what kind of car? Well, I want to ride in a fancy, I want to ride in an SUV. Okay, well, what kind of SUV? I want to ride in a Ford SUV. Like, you can get so specific and go down this track. I want a quadrilateral. Oh, well, what kind? Well, I want a parallelogram. Well, what kind of that? I want a rectangle. Like, we can kind of go down the same route. So that's my words for 3. 4, which shape had the greatest number of descriptions? Square. It's because squares are the most specific type of quadrilateral. They have the most requirements to be a square. There are lots of these shapes that are a square with one of the things removed, right? Like if we pull away E, we have a rhombus. If we pull away the right angles, we have a rhombus. If we pull away the congruent sides, we have a rectangle. If we pull the congruent sides and the right angles away, we have a, nope. We have a parallelogram, yeah, okay. All right, which shape, yeah, we talked about that. Oh, that went down here. Typo. Okay. 2 shapes in the card sort that could only be classified as quadrilaterals. They're shown below. What is the same about these 2? What is different? So there's a lot that these have in common. They both have 4 sides. They both have no congruent sides within themselves. No congruent angles. Oh, excuse me. That we can see at least, no congruent angles. They don't have parallel sides. But if we want to talk about something different, this one has a dent in it. That dent is not what we call that. The math word that we use for that is concave. So it has a concave in its side. When it does not have a dent, when it's, I would call this normal, because this is what I think of. When I normally am thinking of a 4-sided figure, I'm not thinking of one with a dent. This is convex. So. All right, so on to our quick notes. We're gonna look at quadrilateral hierarchy now. Hierarchy. So, if you want a more detailed version of this, it's on the Mathematic website. Let's look at the family of quadrilaterals. If we have all the quadrilaterals, there's 3 options for its sides being parallel. Either we have 2 sets of parallel sides, which is what I mean by that. I mean, that's the symbol for parallel. If you don't know what that means, you might want to say 2 sets of parallel sides. We're going to make just kind of it's kind of a flow chart. So quadrilateral is either 2 sets of parallel sides, 1 set of parallel sides, or no parallel sides. So the only extra classification we have if it has no parallel sides is it can potentially be something called a kite. And so kites were well, you saw the kite earlier. 1 set of parallel sides, this is the family of trapezoids. So with trapezoids, there's a specific kind called an isosceles trapezoid. And just a reminder, that had the those two guys are equal. So those are one set and no sets. We have two sets of parallel sides. There's a bunch of classifications. Excuse me, oh goodness, what a yawny video. So two sets of parallel sides fits it into the family of parallelograms. And your two options from here are you either have, well, you can just be a parallelogram, but you could have 4 right angles. And in that case, you are a rectangle. You could have 4 congruent sides. And in that case, you are a rhombus. If you have both, then you are a square. So square has the most complicated. And again, this is going from general all the way down to the very specific. I wrote specific. So each shape is all the ones above it. So an isosceles trapezoid is a quadrilateral. Excuse me. Grab a drink. Complete the sentence with always, sometimes, or never. So a square is blank, a rectangle. Let's see. Well, that's a square. It is everything above it. And rectangles are there. So a square always comes from rectangles. I'm going to use A for always, S for sometimes, N for never. A parallelogram is always or sometimes or never a rhombus. Well, here's parallelogram. And so above it is quadrilateral. So every parallelogram is a quadrilateral. But parallelograms can just be themselves. They can be a rectangle. They can be a rhombus. Oh, they can be a rhombus. Okay, sometimes. Trapezoid and rectangle. Is a trapezoid ever in the same flow of rectangle? No. Rectangles are over here with the 2 parallel sides. Trapezoids are not. So never. A rhombus is, sometimes it's just a rhombus, sometimes it's a square. So sometimes. A rhombus is, let's see, can a rhombus be anything but a quadrilateral? Well, no, it's at the top. So it's always a quadrilateral. All right. 2 more interesting ones that I want to put on here. No, one more, sorry. A square is always a rectangle, but a rectangle, think about this. Is a rectangle always a square? Well, no. Square is a more specific form of the rectangle. So that would be sometimes. All right. So if you're trying to pick the most specific name to give this, if I were you, I'd probably want to put square. It looks like a square. But we're not guaranteed that this and this are 90 degrees, so I can't call it a square. Do I have 4 right angles? We don't know. That's 90, but we don't know what those are. And sure, it looks like a square, but you know, we can redraw it, so pretend it's a 90-degree angle and then have it kind of stretch out that way and have that and that still equal to each other. So there's lots of strange things that we can do. So I can't guarantee those are 90 degrees. So not that. I don't have 4 congruent sides necessarily. I think that helps show that. 2 sets of, no, I can't prove that these are parallel sides. I don't know what these angles are. I don't even have 1 set of parallel sides, so this doesn't have any parallel sides. Is that enough to say a kite? The website says that's enough to say a kite, but I don't know how we know that these two are congruent to each other. They look it, but that's not a good explanation. Let me see if I can, if I put this line in here, then we have side, side. This angle, that should be split in half. I don't know. All right, so if you said quadrilateral, I would take that. If you said kite, I would take that. All right, 3, find the area and perimeter of this. So this is gonna revolve around the Pythagorean theorem, which we are going to spend some time on, but not right now. So I'm gonna tell you that this side here is 2. So if that side's 2, then that side's 2. If that side's 4, then that side's 4. You can ignore that. So then the area is base times height, or length times width, which is 4 times 2, or 2 times 4, which is 8. And the perimeter is 2, 2, 4, 4, right? You could say it's 2 times the length plus 2 times the width, or 2 times the base plus 2 times the height, or 2 plus 2 plus 4 plus 4, which is 12. All right, sketch a picture and explain why it's impossible. Or explain why it's impossible. Spoiler alert, these are both impossible. A parallelogram with 1 obtuse and 3 acute angles. 1 obtuse, but parallelogram says we have 2 sets of parallel sides. So whatever this angle is, this angle has to match it. And whatever this angle is, this angle has to match it. That's always gonna happen. So I can't just have 1 obtuse angle, because if there's 1, there will be another one. So, nope, can't do it. And then a concave trapezoid. Well, if you remember, trapezoids are required to have 2 parallel sides. So concave is where it had like a dent or a cave-in in it. So like, can I do that? So that's concave. It's got a little dent, but it's not a 4-sided figure anymore. 1, 2, 3, 4, 5. It's a 5-sided figure. There is no way for us to have these parallel sides and have some kind of dent. Like, well, if you went over that way and just cut that off, well, that's not a dent. It's just a slant. So there's no way to put the dent in there. All right, let's move on to more. Oh, this is the homework. Right, okay. So, hope that was helpful. Bye.